Article will see conductors and insulator. What are conductors? Conductors are the material or substances which allow electricity to flow through them. Conductors are materials or substances which allow electricity to flow through them. Conductors contain large number of free electrons. These electrons are loosely bound to the nucleus in the conductor. In next article we will see insulator. What is insulator? Insulators are materials or substances which do not allow electricity to flow through them. Insulator are materials or substances which do not allow electricity to flow through them. As we know that insulator do not contain free electrons, so these free electrons are tightly bound to the nucleus in the insulators. What is free charges? Conductors contains large number of electrons, free electrons. These electrons are loosely bound to the nucleus in the conductor. These electrons are easily drifted in opposite direction when field of the field when external electric field is applied. These charges are called as free charges, means loosely bound electrons to the conductors are called as insulator. Similar to free charges, there also exist bound charges. The nucleus, which consisting positive ions and the electrons in inner shells, remain held in the fixed positions. So these immobile charges are called as bound. Next is there are some properties of electrostatic conductor. First property, in the interior of the conductor, net electrostatic field is zero. Second, the potential is constant within and on the surface of a conductor. Second property. Third, in static situation, the interior of the conductor can have no charge. Fourth one, electric field just outside a charged conductor is always perpendicular to the surface of a conductor at every point. And last one, surface charge density of a conductor could be different at different point. Next article, we have already studied this article dielectrics in 11th standard. So dielectrics are the insulator which can be used to store electrical energy. Dielectrics are the insulator which can be used to store electrical energy. There are two types of dielectrics. First one is polar dielectrics and second one is non-polar dielectrics. We'll study what is polar dielectrics and non-polar dielectrics in detail in next slide. What is electric polarization? When dielectric substance, actually dielectric substance is insulator, okay? When these dielectric substances are placed in external field, their positive and negative charges get displaced in opposite direction, and due to the displacement of charges in opposite direction, the molecule developed net dipole moment. So this total phenomenon is called as what? Electric polarization. So what is electric polarization? When dielectric substances are placed in an external electric field, their positive and negative charges get displaced in opposite direction and the molecule developed a net dipole moment. This is called as polarization of a. We will see polar molecule or polar dielectrics. Here, in figure shows that the center of mass of positive charge does not coincide with the center of mass of negative charge. Here, what is polar dielectrics? A molecule in which the center of mass of positive charges do not coincide with the center of mass of negative charges because of the asymmetric shape of the molecule is called as polar molecule. A molecule in which center of mass of positive charge does not coincide with the center of mass of negative charge because of asymmetric shape of the molecule is called as polar molecule. In polar molecule have permanent dipole moment of order of 10 raised to minus 30 coulomb meter. They act as a tiny electric dipoles as the charges are separated by a small distance. Dielectric material like HCl, hydrogen chloride, water, alcohol, ammonia, etc. are made up of polar molecules and are called as polar dielectrics. For example, here water molecule has a bent shape with its two OH bonds which are inclined at an angle of about 105 degree. Water molecule has a high dipole moment, and that is near about 6.1 into 10 raised to minus 30 coulomb meter. Here is an example of HCl molecule, non-polar dielectrics, and here example of H2O molecule. So this H2O molecule shows that this angle is exactly near about 105 degree. We will discuss non-polar molecules. Here look at in the figure. Here the center of mass of positive charges coincide with center of mass of negative charges. So what is non-polar molecule? A molecule in which the center of mass of positive charges coincide with center of mass of negative charges because of symmetric shape of the molecule. So this is called as non-polar molecule. A molecule in which center of mass of positive charges coincide with the center of mass of negative charges because of symmetric shape of the molecule is called as non-polar. These are symmetrical shapes and have non-zero dipole moment in normal state. These molecules are symmetric but have zero dipole moment. Examples, some of the examples are given here. Nitrogen is there, hydrogen, oxygen, CO2, benzene, methane are made up of non-polar molecules and also called as non-polar substances. Look at here example of hydrogen molecule here, HH, both having same, so this molecule is called as non-polar molecule. Another example is CO2 here, their center of mass of positive and negative charge exactly coincide, so this molecule is called as what? Non-polar molecule. So some of the example. Okay, now here the polarization of non-polar dielectrics in external field. Polarization of non-polar dielectrics in external field. Look at this is example here. This is example of what? When non-polar molecule or dielectrics in absence of electric field, and this is again diagrammatic representation which shows non-polar molecule dielectrics in presence of external electric field. If you look at the figure, in absence of electric field, here the center of positive charge and negative charge get exactly coincide. Okay, and in this case here negative charge and positive charge get shifted when external electric field is applied. So explanation is given. When an external electric field E0, when an external electric field E0 is applied on non-polar dielectrics, the center of positive charge is pulled in the direction of E0 while that of the negative charges are displaced in opposite direction. Okay, if I draw a diagram here, I will show here example. Here this is diagrammatic representation. This molecule get displaced like this, so it contains here negative charge and here positive charge. Okay, before that the molecule are coincide, positive charge, center of mass of positive charge and negative charge is exactly coincide. So this is original position when E0 is 0, means absent, E0 is absent, and this is after application of what? E0, it get displaced. Okay, now here therefore the two centers are separated, and molecule get distorted. The displacement of charges stops when force exerted on them by external field is balanced by restoring force between the charges in the molecule. Means here displacement, total displacement totally depends on what? Restoring force between the charges. Each molecule become a tiny dipole having a dipole moment. The induced dipole moment of all molecules, in different molecules, add up and giving some net dipole moment in case of non-polar molecule. Now we'll see here polarization of polar dielectrics in external electric field. Look at here. In previous diagram we have seen that for non-polar molecule. Look at here, they are slightly tilted. It means that here the center of positive charge and negative charge did not exactly coincide with it. Okay. Now look at here. In absence of electric field, here E is equal to 0. They remains their steady positions as it is. Okay. When polar dielectrics in presence of external electric field, here positive charge pulled in the direction of what electric field, while negative charge is in the direction of opposite to direction of electric field, in opposite direction. Here look at the molecule of polar dielectrics have tiny permanent dipole moments, and non-polar have zero dipole moments. Due to thermal excitation in material, in absence of any external field, these dipoles are randomly oriented, hence total dipole moment is zero. Important points: total magnetic moment when external electric field is zero, total dipole moment of the dielectric substance is zero. That is polar molecule. Next, when an external electric field is applied, the dipole moment of different molecules tend to align with the field. Same. As a result, dielectrics develop a net dipole moment in the direction of external field. Hence, dielectric is polarized, and the extent of polarization depends upon relative values of the two opposing energies. Okay, this is explanation regarding to what polar and non-polar. And what is polarization? The dipole moment per unit volume is called as polarization. The dipole moment per unit volume is called as polarization. It is denoted by letter P. Its SI unit is coulomb per meter square. In linear isotropic dielectric material, P is equal to chi e. This is actually Greek alphabet chi. It is called as chi. P is equal to chi e. Okay, where chi is electric susceptibility of the material. It describes what this chi describes means. Susceptibility describes the electrical behavior of dielectric substance. It has different values for different dielectrics. In this article, we will see reduction of electric field due to polarization of dielectrics. When a dielectric is placed in external electric field, the electric field inside the dielectric is less than external electric field. It shows that the applied electric field must be greater than the electric field induced in the dielectric slab. Now consider a rectangular dielectric slab placed in uniform electric field E, acting parallel to two of its faces, which is shown in the figure. This is dielectric slab and we are applying here electric field. This electric field produces a slight rearrangement of charges within the atom, resulting in aligning them with the field. If you look at the figure, this dielectric slab contains positive and negative ions. These positive ions move in the direction of electric field, while the negative ions move in opposite direction of electric field. So there is slight rearrangement of charges which will produce here some dipole moment. As the result of alignment of dipole moment, there is an apparent sheet of positive charges on the right side and negative charges on the left side of the electric. So here if we see in the figure, then figure shows that the dielectric slab, so here positive charge is produced on right side and negative charge is produced on left side. So due to alignment of this positive and negative charge, the sheet of induced surface charges produce an electric field E0. This is electric field due to polarization of dielectrics, which will oppose the electric field E. So E0 will oppose E. Therefore, the net electric field E dash inside the dielectric is vector sum of electric field E and polarization of field E0. So therefore, E dash is equal to E minus E0. So this equation shows that how does the polarization of dielectric reduce the electric field in a dielectrics. Now this is total diagram. The diagram shows how does the electric field reduces due to polarization of dielectric.